So here we've got some data and it's represented by y equals minus 0.275 plus 1.8x. Now we want to code the data using y equals log base 10 of y and x to be log base 10 of x. And then what we're going to do is find the new model to estimate our values on this line here. So how are we going to do that? Well, as y is log base 10 of y, I'm going to substitute that in for the y value. So log base 10 of y, and then minus 0.275, and then plus 1.8, and then as it's x, we're going to code it log base 10 of x. So 1.8 log base 10 of x. Okay, and now out of that, what we've got to try and do is get the y and the x's away from the log values. So what we do now, we can raise both sides to the power of base 10. So if I do 10 to all of that, I'll then end up with 10 to log base 10 of y equals 10 to the minus 0.275 plus 1.8 log base 10 of x. So that's a way to do this line of working. And as we've got 10 to the log base 10, these two will cancel out and I'll just be left with y. So that would take care of that. And this one here, using the laws of indices, as it's added, I can just multiply these two together, base 10. So this side and this side. So that will look something like this. Minus 0.275 times 10 and then 1.8 log base 10 of x. Okay, now this will equate to just a value. So we can plug that in our calculator, get an approximate value of that, which is 0.53. And then this one here, I've got 10 times 1.8 log base 10 of x. Now using log property, I can use 1.8 and raise this x to the power of that. So I've now got times 10 to the log base 10 of x to the 1.8. And that's valid to do that. Okay, so now I can rewrite this. Y equals 0.53. 10 to the log base 10, they will cancel out and leave me with x to the power of 1.8. So x to the 1.8. So I put little times in there. And that be my new model. So we can rewrite that as y equals 0.53x to the 1.8. 0.53 here is just a coefficient. It's x raised to the 1.8. And that will be my new model using coded y log base 10 of y and x log base 10 of x. And that takes care of that.